In this video, we will have our lesson on tangent and normal lines. So, um, I'll get straight to what you have to know. The formula for the slope of a tangent line is equal to the limit as delta x approaches 0 of delta y over delta x. This is equal to dy over dx, which is equal to the derivative of the function. This can be rewritten as limit as delta x approaches 0 of, basically this is the definition of derivative. So let me show you an illustration of basically the relationship between a tangent and a normal line. So we have this, we have a curve. So if this is our tangent line, so basically this is the intersection, the normal line is going to be perpendicular of it. Here. Normal line. Therefore, you could say that the normal line is perpendicular to the tangent line and the point of tangency. The point of tangency is right there. So if you want to look for the slope of the normal line, so given that you have a tangent line slope, so it's basically going to be its negative reciprocal. So we will be using point slope form. So y minus y sub 1 is equal to the slope of the normal line times quantity x minus x sub 1. In the same way, you can rewrite this, but in terms of the slope of the tangent line, it's written as this. So let's get to, let's try out an example immediately. So you have this, I believe this is a quadratic equation, expression. You have a coordinate, so 0.12. Given these details, you are tasked to find the equations of the tangent line and the normal line. So how do you do that? Basing on what we are given, we all know that the slope of a tangent line is equal to the derivative of f of x, as stated earlier. So what we do is find the derivative of this. So 6x minus 2. This is our MTL. And we are given a coordinate, right? So let's try to substitute x as 1. So 6 times 1 minus 2. 6 minus 2 is 4. This is the slope of our tangent line. So using the point slope form, also using the coordinates, the point that we were given earlier, so y minus 2. Let me write the formula first. Let me just clarify this. Regardless if it's not necessarily that you write in terms of slope of tangent line this way. You can write the equation this way. So it doesn't really matter. Depending on what you're provided, in this case, you have the slope of the tangent line. You can construct the equation like this, It doesn't have to be like this. So y minus 2 equal to 4 times x minus 1. If you turn this into, I believe this is called slope-intercept form, so only y is at the left side, you have this. So that is the equation of the tangent line already. If your MTL is equal to 4, therefore your the slope of your normal line is going to be the negative reciprocal, or negative 1 over 4. So using this format again, so y minus, basing on the coordinate, 2 equal to negative 1 over 4 x minus 1. So if you turn this into slope intercept form, so this is the equation of your normal line. That's it. Next question. You are tasked to find the points of intersection of the normal line to the curve y is equal to x squared minus 4 divided by x, where m is equal to 2 with the line x minus y equals to 0. So the slope of the tangent line is equal to the derivative, right? So let's find the derivative of this curve. So quotient rule, x times 2x minus, damn, anyways, copy and then times 1 divided by x squared, 2x squared minus x squared plus 4. Okay. So we want to know what slope is this referring to. Is that for the normal line, or does it mean off the tangent line? So we determine that by, since what's related to the curve is usually associated with the tangent line. So where m is equal to 2 to the curve. So this is most likely the slope of our tangent line. From there, so since we identified that that's our tangent line slope, we equate this derivative to 2. And from there, let's try to find x. We'll multiply both sides by x squared. Then we'll have 2x squared. X squared equal to 4. X is equal to plus minus 2. Okay. At x is equal to positive 2, the point of tangency is what? So we're going to use the curve y is equal to, we just substitute x as 2. 2 squared minus 4 over 2. That's equal to 0. at x is equal to -2, the point of tangency is what? -2 squared minus 4 over -2, still 0. So we have coordinates 2, 0 and -2, 0. And continuing on, the point slope form. For a while. So we're basically going to use the equation involving the normal line. So y minus 0 and then -1/2. There you go. Y is equal to -1 over 2x plus 1. For the other side, same thing. Y is equal to -1/2 x minus 1. So what's the next step? We are given a line x minus y equal to 0, right? So what you would want to do is basically turn these two equations into, well, basically x and y are in one side, let's say the left side. So 1/2 x plus y equal to 1. We can turn this into x plus 2y equal to 2. On the other side, 1/2 x plus y equal to -1. X plus 2y equal to -2. So now we write x minus y equal to 0. Use systems of linear equations to identify x and y, and they will be the points of intersection of the normal line to this curve. So proceed. Let's try minus. Elimination method. 3y is equal to 2. Y is equal to 2 over 3. Other side. Minus also. 3y is equal to -2. Y is equal to -2/3. X minus 2/3 equal to 0. X is therefore equal to 2/3. X minus -2/3 equal to 0. That's going to be positive. When you move it to the left, it's going to be a negative. So summary, 2/3 and 2/3, -2/3 and -2/3. So these are the points of intersection. Okay, next question. Okay, this time we are tasked to find the equations of the tangent line to the ellipse x squared plus 2y squared is equal to 9, such that it is perpendicular to 4x minus y equals to 6. So this is a line. What do we do with this characteristic that has been described? We'll get to that later. What's the easiest to find? Usually you do that step first. We can identify the slope of this line, and later we identify whether it's off the normal line or off the tangent line. So negative y is equal to negative 4x plus 6, y is equal to 4x minus 6, m is equal to 4. So is this off the normal line or off the tangent line? So like I said before, whether it's an ellipse or a curve, anything that's along with it is related to the tangent line, and whatever is therefore perpendicular to what's related to a tangent line is off a normal line. What's another way of describing that? So let's say the ellipse, just imagine that it is directly related to the tangent line. So whatever is perpendicular to it is going to be off the normal line. Therefore, this one, our 4 value, is the slope of the normal line. From there, you can derive what our tangent line's slope is. That is going to be negative 1 over 4. So going back to the ellipse, before we start deriving, let me think. So yeah, before deriving, let's rewrite the equation like this. Divide both sides by 2. Square root both sides. We could merge these two. Same LCD. And I think we can also rationalize. So we'll get 2 square root of 2 and like that. And from there, I think we can start deriving. So we set aside the constants. What we have left is, wait, for what? 9 minus x squared raised to 1/2. We can rewrite into this, and then we apply power rule. So 1/2, 9 minus x squared raised to negative 1/2, and that. And then let's try to simplify. It's negative 2x okay. We can cancel. Okay, so this is the slope of our tangent line, and we identified earlier that its value is negative 1 over 4, right? So from there, let's try to identify what the x value is. So multiply both sides by 4, cancel. 2x square root of 2 over square root of 9 minus x squared, negative 1. Multiply both sides by the square root of 9 minus x squared. So these will cancel. 2x square root of 2 is equal to negative square root 9 minus x squared. I think what we do is square both sides. So 4x squared times 2 equal to negative 9 minus x squared. Negative 9, positive x squared. Oh, are we in the right tracks? I almost forgot. The negative sign, right? So this has to be negative. Therefore, both of these will be positive. Okay, so far so good. Wait a minute. So this is still gonna be a minus. If you transpose x squared to the left side, we'll have 9x squared and then 9. X squared equal to 1. X is equal to positive minus 1. Okay? And we will use the ellipse. Before we found its derivative, we'll use this. So before deriving, we substitute to identify the y value. So square root of 2 times four squared. So 4 over 2 is equal to 2. There you go. That's from x equal to positive 1. Positive 1, positive 2. How about for if x is equal to negative 1? It doesn't change anything, I think. Let's confirm that. 9 minus 1, 8. 16, 4, 2. So negative 1 and 2. Now let's whip out the point slope form. So since we have the slope of tangent line, that's what we're dealing with right now. Again, we are tasked to find the equations of tangent line. That's why we use MTL. So 2 as y1, MTL is negative 1 over 4, x1 is 1. And I think this is called the general form. I mean, it basically means x and y are in the left side and the constant is at the right side. That's what we're gonna do. So y minus 2 equal to negative 1 over 4x plus 1 over 4. 1 over 4x plus y equal to 2 plus 1 over 4. 8, 9, 9 over 4. So this is one of the equations. So same thing, y minus 2 equal to negative 1 over 4 times quantity x minus negative 1. So y minus 2 is equal to positive, negative 1 over 4x plus y is equal to 2 minus 1 over 4. 8, 7. Okay, these are the two equations. Can we condense the solution as much as possible? I think that's it. How many questions do we still have? 1, 2, 3, 4, 5. 4 questions left. Let's keep going. It's either I do 4 or 3. Depends if I feel generous. So find the tangent line to the curve y is equal to x raised to 4 plus 2x cubed minus 2x squared minus 3x plus 3 perpendicular to the line x minus 3y equal to 2. So what's our first instinct? Find the slope of this line. So negative 3y is equal to negative x plus 2. So whose slope is this? Since we have the curve and it is perpendicular to the line, so this means this is the slope of the normal line, which also means the slope of the tangent line is negative 3. So let's find the derivative of the curve. MTL is equal to the derivative of the curve, which is equal to 4x cubed plus 6x squared minus 4x minus 3. Okay, that's equal to what? Negative 3. So at this point, we ought to find the value of x. And there definitely there will be more than one value for x. So let's continue. If you transpose this to the left side, these two will cancel. So I think we can factor something. So these are the x values. So what do we do now? For each, let's start first with x equal to 0. Let's copy the curve equation. Substitute to identify the y value. So everything's gonna be 0, 0, 0, 0, plus 3. Y is equal to 3. Therefore, we have the coordinate 0, 3. Next, if x is equal to 1/2 raised to 4 plus 2 times 1 over 8 minus 2 times 1 over 4 minus 3 times 1 half plus 3. 1 over 16 48 uh, 5 15 7. Okay, so y is 21 over 16. By the way, going back to 0, 3, we can already use the point slope form. So y minus y1 is 3. MTL is what? It's equal to negative 3. So okay, this is one equation of the tangent line. How about here? So 1 half 21 over 16. Therefore, okay. Next, given that x is equal to negative 2, (16) y is equal to 1. So y minus y1 equal to the slope of the tangent line, x minus negative 2, or just x plus 2. Okay, that's it for this question. Next. So find the equations of tangent line and normal line to the curve y is equal to square root of x over x plus 1 at 4 2/5. So we're not given a line, so let's immediately find the derivative of our curve. So x plus 1 times wait okay. I think at this point, even before deriving, I hypothesized it would lead to the same answer. But since we're given to coordinate, we can already substitute x as 4. So 4 plus 1, 2 square root of 4 minus square root of 4. Let's just say 2 plus 1 squared. 5 over 2 times 2, 2, 9. Wait a minute. Sorry. This is supposed to be 4. I perceive this as square root of x. So 25. Negative 3 over 4 times 1 over 25. Negative 3 over 100. This is the slope of the tangent line. Therefore, the slope of the normal line is 100 over 3, positive. So, again, we are tasked to find the equations of tangent line and normal line. So, let's start first with normal line. Point slope form. We are going to use this point for the x1 and y1. So, slope of normal line is 100 over 3. Five 2000. So that's for the normal line. How about for the tangent line? Okay, that's it. Next. So we are tasked to find the parabola in the form y is equal to ax squared plus bx plus c. That has a slope of 4 and x equal to 1. Another slope, m is equal to negative 8 at x equal to negative 1 and passes through the point 215. So we're tasked to find the parabola itself, the curve, in the form x squared plus bx plus c. So what do we do given these values? This question is quite different from what we've previously answered. So MTL is equal to 2ax plus b. We basically found the derivative of the format. So we'll be using this equation twice, using m4 x equal to 1, m negative 8 x equal to negative 1. So 4 is equal to 2a times 1 plus b. 4 is equal to 2a plus b. Using the other given, negative 8 is equal to m. 2a times negative 1 plus b. Negative 8 is equal to negative 2a plus b. Systems of linear equations to identify a and b. 2a plus b equal to negative 8. 2a plus b equal to 4. Negative 4a equal to negative 12. A is equal to 3. 2 times 3 plus b equal to 4. B is equal to 4 minus 6. B is therefore equal to negative 2. So from there, using the format, y is equal to 3x squared plus minus 2x plus what is our c going to be? We don't know yet. It says passes through the point 15, 215, right? So, so let's try, given this equation that we already have, substitute 15 and x as 2. Then you'll find c. 12 minus 4, 8, 7. So c is equal to 7. Therefore, 3x squared minus 2x plus 7. This is the parabola. Okay. Last question. Where does the normal line to parabola y is equal to x minus x squared at point 1, 0 intersect the parabola the second time? So your MTL, find the derivative already. 1 minus 2x, right? And what else? So since you have a point 1, 0, so substitute x. So 1 minus 2 times 1. Negative 1 is equal to your MTL. Therefore, your MNL is going to be negative 1 over 1. Sorry. The opposite, so positive 1. But we are focusing on the normal line. So bring out the point cloak form. Coordinates y minus 0 equal to 1 times x minus 1. Y is equal to x minus 1. What do we do next? We need to find x and y. So given that we have these two, so bring this here. So I think we apply systems of linear equations. Or No. We can't. I don't think it's appropriate to use elimination method or substitution method here. Since both of these are equal to y, we can just equate them. So we'll get something like this. So x is equal to plus minus 1. So clearly, since we're given the point 1, 0, if x is equal to positive 1, then y is 0. That's why we have 1, 0. What if x is equal to negative 1? Y is equal to what? So negative 1 and what value? How do we identify that? I believe you can use the parabola equation itself. So y is equal to negative 1 minus negative 1 squared. Negative 1, negative 2. So this is the other point where the normal line intersects the parabola the second time. So that's it. This is the other point of intersection, basically. Okay, I'll end the video here. Next video will be about rate of change and related rates.